Okay, so we're going to talk about annuities here. Now, before we do that, let me back up a little bit what we have talked about in the past. We've talked about like investing an amount, and this is if you're compounding annually. Compounding annually. That's the formula. So you take the principal, how much you invest, and then you figure out, R is your rate of interest, how much they're giving you on it over so much time. And that's how you figure out like what you would make after so many years if it's compounded annually. Then we had another formula that was P times 1 plus R divided by N to the NT, and that's compounded N times a year per year. So if it's quarterly, then N is 4. If it's monthly, N is 12. And we did some problems like that. Okay, so that is when you take some money and you just invest it. You say, here's my $5,000. I'll be back in 20 years. And then you give me a bunch of money plus my interest. Okay, that's what those formulas are. An annuity is a little bit different. An annuity, you're putting in, you're adding to the investment on a regular basis. So like IRAs are often done this way, and you say, okay, well, I want you to take, $1,000 out of my paycheck every month and put it in this account, my IRA. So you don't have a set amount that you're investing because it keeps growing. You keep putting more money in, and then you keep earning more interest on that money that you've put in. And that's the idea behind an annuity, so you can have enough money to retire. Trust me, that's a good thing to try to have. Okay. So when you first invest, like the first month, you're putting in P, right? Okay. Now, if this were done annually, then the next time you would have P times 1 plus R. Okay. And then you'd keep multiplying by that 1 plus R. And it'd be squared plus, and then it'd be the principal times 1 plus R cubed plus, and then it's going on until you get to the last payment that you're going to make, when you're done working after so many years, T minus 1. Okay, so this would be your rate of interest, R, based on your annuity. The P, oops, I keep doing that. The P is how much you invest each month or each year. Each year. You're adding to the investment. And then the T is the number of years. Okay, now this is one based on annually, right? Well, then over time, you're going to add up all these amounts. That's why it's a sum, is because you're adding up, okay, this is how much you put in the first year, then this is how much you're going to have in the second year, and then the third year, and so on and so forth. Okay? Now, they show you this in more detail in the book. But if you go and use the other formula based on compounded, not necessarily yearly, but monthly, and they put that in to our sum formula, and they get this gigantic formula right here. So that's the value of an annuity, interest compounded N times per year. Okay, so if you're going to do it monthly, then N is 12. If you're going to do it quarterly, N is 4. The rate of interest is still R. P is still how much you're investing each month, okay? And then T is how many years you're going to be doing this. Okay. So that's the formula we're going to use. So it says in our example, at age, I'm not going to memorize that formula. I'm going to put that on my note page. Okay. At age 25, to save for retirement, you decide to deposit $200 at the end of each month. Okay. Good thing you started when you were 25. Don't wait till you're like 50 like me. Start when you're young. Okay. At the end of each month, you're going to deposit $200 into your IRA, and it has a historical return value equivalent to 7.5%. Now, let me explain that a little bit. So a lot of times these accounts, they fluctuate the percentage that you're going to make. So they're just saying, okay, in the past, historically, it's been about 7.5%. So that's what we're going to base it on. We're going to predict how much money we're going to have. So it might not be exact. And we're compounding monthly, okay? So using the historical rate of return, how much will you have from the IRA when you retire at age 65? So we're going to work for 40 years, okay, from 25 to 65. So my T is going to be 40. My rate of return, okay, so that comes from the percentage 0.075. We have to write it as a decimal. N comes from the compounding. We're compounding monthly, so N is 12. And then how much are we putting in? The P is $200. That's what we're putting in. Okay, so I think I'll go, let's see, where can I put this so you can see it really well? How much money am I going to have? I'm going to use the formula right here. It's going to be 200 times 1 plus 0.075 divided by 12 to the power of, now it's going to be n, give myself a little more room, n was 12 times 40, because it's 40 years, right? And then minus 1, and then close that off with a bracket, divided by, and then it's divided by r, whoops, I'm putting in the values, right? R was 0.075 divided by 12. Okay, so you see that's in two places. Okay, now how am I going to put this in the calculator? Well, there's a couple ways I could do it. I'm going to lose sight of this. I'll try putting it in different colors, see if that helps. So I'm going to put 200, and I'm going to put parentheses around this. Parenthesis, 200, parenthesis, parenthesis. So that's this one and then this one. 1 plus 0.075 divided by 12. And then it's to the power of, now I'm going to go ahead and multiply that out. 12 times 40 is going to be what? 480? Minus 1. Don't forget that 1. That closes off the parenthesis. Okay, so you got to match up your parentheses. You're going to need another parenthesis. So do you see them? So like here's the green parentheses. I'll try to make it so you can see it a little bit better. Here's the blue parentheses right here. Matches to this one. And then here in black, that's that parenthesis matching with that parenthesis. Okay, hopefully that helps. Divided by, and then I'm going to open another parenthesis, 0.075 divided by 12 and close that off. Okay, now they do it a little bit differently in the book. They actually put in some of the numbers. They figure out what 0.075 divided by 12 is. But if I wanted to put it all in my calculator at once, this is what I would type in. So stop the video and try typing that in and come back and we'll see if we have the same answer. Okay, so what did I get for this? I got, this is giving me my answer to part A, 604764. And that's to the nearest dollar. Okay. So $604,764. Now, in the textbook, they must have rounded off a little bit early because they got 604,765. Okay, but mine's just a little more accurate because I didn't round off. Okay, and there's pennies involved, but we're just rounded to the nearest dollar. Okay, so that is that part. Find the amount earned on your investment. So how much money did you really make? You kept putting money in, right? So part B, how much money did you put in? You put in $200 and you did that for 480 months, right? So if you just took $200 every month and you put it in the mattress, you just add up that $200, what do you get? Well, let's see. 200 times 480. Okay, you get $96,000. So if you had just taken your $200, you didn't invest it, you just put it in your under your mattress, and you did that for the whole 40 years, every month you put $200 under the mattress, then you would have gotten $96,000. But you invested, so you got more money. So you got that much more money. Now, how much did you earn then? Your earnings are going to be the 604,764 minus 96,000. So what's that? Let's see. 604,764 minus 96. Okay, so you earned $508,764. So not bad, right? Like you got a lot more money by investing than if you just put $200 in your mattress every month. Okay, that's an annuity.